Have you ever wondered how the world map might look a few million years from now? Specifically, how will the geography of Africa change? These questions might sound like science fiction, but they're rooted in a fascinating geological phenomenon currently unfolding in the heart of Africa. The African continent, as we know it, is on a slow but steady journey of transformation. This process is driven by seismic activities along the East African Rift System, a massive geological trench that stretches thousands of kilometers across the eastern part of the continent. In the year 2005, scientists discovered a significant rift in this system that has been extending and widening each year. Picture this, a massive geologic crevasse stretching out and growing wider year after year under the relentless forces of nature. This expansion suggests that, given enough time, a new ocean could eventually form, effectively dividing Africa into two large rocky blocks. But what's causing this gradual separation? The answer lies deep beneath the Earth's surface, in the movements of the planet's tectonic plates. The African continent, like all landmasses on Earth, rests on these gigantic slabs of rock that float on the molten mantle beneath the Earth's crust. In Africa's case, the continent sits on two major tectonic plates, the Nubian plate and the Somali plate. These plates are slowly but surely moving away from each other along the Rift Valley. This movement is causing the Earth's crust to thin and stretch, leading to the formation of the rifts we're seeing today. While this process might sound dramatic, it's important to remember that we're talking about a timeline of millions of years. The rate of change is measured in centimeters per year, not kilometers. The current rift extends over 3,000 kilometers across Africa and is widening at a rate of between 2.5 to 5 centimeters annually. This monumental shift in Africa's geography is caused by the movements of tectonic plates, particularly the Nubian plate and the Somali plate. Tectonic plates, as you might know, are enormous pieces of the Earth's crust and upper mantle, floating on the planet's molten interior. They're like giant puzzle pieces, constantly moving and interacting in a slow, eternal dance. But what happens when two of these colossal plates decide to part ways? Well, that's exactly what's happening in Africa. Let's focus on two key players in this geological drama, the Nubian plate and the Somali plate. These two tectonic giants cover a vast territory, from the heart of Africa to the Arabian Peninsula. They're currently engaged in a slow-motion breakup, and the evidence of their parting is the East African Rift Valley, a geographical feature that spans an impressive distance from Jordan in Southwest Asia to central Mozambique in southern Africa. So how does this work? Imagine two massive slabs of rock floating on a molten sea of magma. Now picture these slabs slowly but inexorably pulling away from each other. This movement creates a gap, a rift, which is promptly filled by the upward surge of magma from the Earth's interior. This molten rock cools and solidifies, creating new crust and over time a widening valley. This is the Rift Valley, a testament to the powerful forces at play beneath our feet. The Nubian and Somali plates aren't just drifting apart anywhere, they're doing so along the Rift Valley. This means that as they continue to move away from each other, the Rift Valley will continue to widen, its boundaries slowly but surely extending. It's like watching a slow-motion movie of a continent being torn in two. But don't worry. This isn't a disaster in the making. This is a natural process, a testament to the dynamic nature of our planet. It's a process that has been shaping our world for billions of years, creating continents, mountain ranges, and ocean basins. The movements of these plates are what's causing the Rift Valley to extend and widen, bringing us to the next point of our discussion. The evidence of this continental split isn't just theoretical. Visible shifts are occurring, demonstrating the continent's fragility and the inevitability of its division. Take, for instance, the notable rupture that occurred in Kenya in 2018. This wasn't just an ordinary crack in the ground, it was a substantial, earth-shattering event, an eye-opening illustration of the silent and relentless forces that are shaping our world. A deep chasm, several miles long and several feet wide, ripped through the earth, leaving an indelible mark on the landscape. But what caused such a dramatic rupture? The answer lies beneath the Earth's surface, in the fiery heart of our planet. Magma, the molten rock that resides in the Earth's mantle, is continually rising towards the surface. As it ascends, it thins the Earth's crust, much like a balloon stretching as it inflates. This thinning process is not uniform, though. It occurs along the path of least resistance, the weak spots in the Earth's crust. In this case, the weak spot was along the East African Rift, a vast fracture in the Earth's surface that stretches from Jordan in Southwest Asia to central Mozambique in southern Africa. As the magma continued to rise, it stretched the crust to its breaking point, resulting in the dramatic rupture witnessed in Kenya. This event was not an isolated incident, but rather part of a continuous process that's been unfolding for millions of years. The rift is currently extending over 3,000 kilometers across Africa and widening at a rate of 2.5 to 5 centimeters annually. It's a slow process, almost imperceptible in human timescales, but the evidence is there, etched into the landscape in the form of these dramatic ruptures. These shifts and ruptures are clear indications of the ongoing geological activities, leading to the eventual split of the African continent. This is a testament to the dynamic nature of our planet, a reminder that even the seemingly solid ground beneath our feet is in a constant state of transformation. While the evidence is clear, this division is not something we should expect to see in our lifetimes. When we talk about geological timescales, we're stepping into a realm where the ticking of the seconds, minutes, and hours that govern our daily lives become insignificant. We're venturing into a world governed by a clock that counts in millions and even billions of years. The East African Rift, a tear in the Earth's crust that spans over 3,000 kilometers across Africa, is a testament to this concept of deep time. It's a slow-motion train wreck that has been unfolding for millions of years and will continue to do so for millions more. The rift is widening at a rate of between 2.5 to 5 centimeters annually. To put this into perspective, imagine a snail, one of nature's slowest creatures, racing against the expansion of this rift. The snail would win hands down, moving at a blistering pace of approximately 7.5 centimeters per hour compared to the rift's top speed of 5 centimeters per year. But while the snail might win the race in our human timescale, in the grand scheme of geological time, this rate of change is significant. It's the equivalent of watching the hour hand on a clock, barely perceptible to the naked eye but relentlessly moving forward, marking the inexorable passage of time. What we're witnessing here is the birth of a new ocean, the creation of two separate landmasses from what we currently know as the continent of Africa. But this is not a birth that will be witnessed by any human currently alive. It's a birth that will take place over the course of millions of years, shaped by the relentless forces of plate tectonics and the slow but steady rise of magma from the Earth's interior. Despite the slow pace, this geological phenomenon is a fascinating example of how our planet continues to evolve. It's a reminder that our Earth, this seemingly solid and unchanging rock beneath our feet, is a dynamic and ever-changing system, always in motion, always evolving. So, while we won't be around to witness this incredible geographical shift, it's a fascinating glimpse into the future of our planet. The world beneath us is far more animated than we might imagine. The same forces that have shaped the world throughout history continue to mold it today, and Africa's potential division is a prime example. The East African Rift System, an enormous trench extending and widening each year, is the stage on which this geological drama is playing out. The silent actors in this act are the tectonic plates, specifically the Nubian plate and the Somali plate. Like two colossal dancers, they are pulling away from each other, stretching the Earth's crust until it breaks. This performance has been going on for millions of years, as slow and steady as the rhythm of the Earth itself. But every now and then, the dance becomes a little more dramatic. In 2018, a notable rupture in Kenya served as a stark reminder of the fragility of the region and the inevitability of Africa's division. This shift was a result of magma rising from the planet's interior, thinning the Earth's crust until it couldn't hold together any longer. But this process is far from over. The rift continues to widen at a rate of 2.5 to 5 centimeters annually, a slow but steady march towards a future where Africa might be split into two large rocky blocks. A new ocean could eventually form, forever changing the face of the Earth. Yet, this change won't happen overnight. It's a process that will unfold over millions of years, much like the formation of the Earth itself. It's a testament to our planet's dynamic nature, a world that's never static but always transforming, evolving, and adapting. As we continue to study and understand these geological activities, we gain a deeper appreciation for the dynamic and ever-changing world we inhabit.